This is setup. The Arduino on the right is frequency generator, and by varying the potentiometer, we will vary the generated frequency between 100 kHz to 8 MHz. And the Arduino on the left is measuring frequency and printing it on the serial terminal. These are DSO readings, which measure and display the generated frequency at that instant. Let us see this in action. Initially, the frequency generated is 100 kHz and the frequency measured by Arduino is also 100 kHz. We will change frequency to 137.5 kHz. We can observe the frequency measured by Arduino is 138 kHz. We will change frequency to 169.7 kHz. The frequency measured by Arduino is 170 kHz. We will now change the frequency to 399.1 kHz. The frequency measured by Arduino is 400 kHz. We will again change the frequency to 1.14 MHz. The frequency measured by Arduino is also 1.14 MHz. We will change the frequency to 3.99 MHz. The frequency measured by Arduino is 4 MHz. Finally, we will change the frequency to approx 7.9 MHz, and the frequency measured by Arduino is 7.8 MHz. Thus, this approach can be used to measure frequencies between approx 100 kHz to 8 MHz.